哎，hello，大家听得到声音吗？可以讲话，让我试个麦。OK，哦，好，OK，我这边是看起来是有录到的，可以。那我们这边就等待那个待会来 sharing 的人吧，我会负责一下转播的工作，这样才比较好录影。看一下，我看那个讯他后来做了很多笔记，耶，好像是被我那个怎么讲，有点像是被我折磨到了。就是因为那个训他上班的时候，就是我有跟他说，如果你不知道怎么读论文的话，你可以找我聊一下。然后他就找我，然后我就是用很严格的方式跟他说你可以怎么看，然后他后来好像就做蛮多准备了。OK，我们就让我在那一串里面也稍微提醒大家。对，right。我觉得，然后 Alan 好像今天不在。然后 that's why。嘿，那个
Hello，OK，
Real，Hello，你今天还好吗？OK 啊，OK。诶，那个 Alan 是有给你他的那些内容吗
也有啦，我
？OK OK，
也有一些吧，
你要讲的内容有很多吗？如果没有的话，我们可
没有
以让那个
没有，
就没有很多。好，那我们就让炫花多一点时间讲好了，我们
嗯，
就让他讲个什么40分钟，
好，
对，这样那个也比较不会那个压力那么大。看一下，我好像是 online 的。好，本来这个读书会的规划方式就是轻松为主啊。像 Alan 他说他好像这周要去参加婚礼吧，我们就反正他上周也有分享过了，我们就让那个比较有空把东西讲一讲就好了。对，然后现在还是在准备阶段嘛，我其实有个想法，有人已经把剩下的内容都读完了吗？就是像是这边 paper 剩下的内容之类的。我会提这个是因为我发现这边 paper 剩下的东西是没有很多，我在想要不要一周还怎么样就把它解决掉。Eric，你有什么想法吗？
我再刷一口，没有，
对，刷一口。
我的像是什么啊？我记得这章结束之后，你可以放大一点吗？
还是对啊，
还是你
有一些啊，看一下哦。
好像第六章好像也
第六
来讲
章在
它的 availability 的东西吧。
对对，因为 All Active Search 是跟卡夫卡很有关系啊，
嗯，
所以他在讲他们怎么实作的。Backfilling related work，我觉得应该最多顶多花2次讲吧。 那就看要不要筛成一次之类的。
可以啊，一次
没关系，
可能好吧，我觉得也可以啦，看看
有点硬。
大家。
我看一下，因为我要综合考虑我们还剩下多少组员。我看一下，我现在剩下谁？我们还有 Titan、Leo， 还有 Lubernetis， 还有圈后。我想一下，好啦，我觉得应该可以分个2组啊，但是我们就先开始好了，2组应该差不多。Kiwi 你可能要关一下麦哦，你的那个背景声比较重。Yeah. Hey Shen, are you there yet?
Hello?
Oh, still the television sound.
Oh, wait, give me a moment.
Yeah, can you?
Is it better?
It's somehow better. I don't really know, but
That's such a.
now because even when we
Why?
talk, sometimes it would pop up.
Oh, god damn it.
Why
Let me
you
see.
always watching the television?
I'm seated right beside a television.
Oh, okay, I
Like,
see.
is your other family members watching it so that you cannot close
Yeah.
it? Okay.
Yeah, they
okay.
are.
You better find
Okay,
your own room.
I don't have a room.
Then move out.
Rent in Singapore is expensive.
Yeah. Okay. Let's hope Shin get to find his own room someday. But I guess Shin, you will still be presenting English, right?
Yeah.
Correct. Okay. That's good. That's good. So we'll have another English session on presenting. So I think you can share your screen, and I'll do the broadcast. And then we'll probably have you talk for around 40 minutes because I think you have more content to walk through.
I was just thinking 30 minutes. Be fine.
No, we demand more.
Oh my god, I'm gonna get grilled.
Okay. Still loading for me. Can anyone see the screen? 其他人看得到吗？
Does Discord hate me? Why does it always have to be like this?
不是，跟我讲一下，你们看到讯的荧幕吗？我看不到。
Bravo. It keeps
Okay.
loading.
It keeps loading. Try again. Sure, please.
Let me reshare.
Yeah, share again. Okay, is it still loading? It's still loading for me.
你快小声一点，跟他讲你要多久聊。
It's still not loading?
It's still loading. Maybe you can try sharing another like application or try to log in again. Yeah, let's try one more time. If you couldn't, I can open the Notion and present for you. Watch.
How?
Okay. I still see nothing. Okay. Do you want to keep trying, or I can do the broadcast for you?
Let me try one more time. Wait.
Okay.
Let me try on a different screen. Okay, let me try one more time.
Right. I have to start the event.
Is there anything?
Yeah. Wait a minute. Let me see. Why can I still not see it? Does anyone Does it work for anyone? Let me try reconnect again as well. Let me try watching Shin's screen. Yeah, I couldn't see anything. I have another account and it still couldn't review anything. I think it's probably just like an application error or something.
Okay. And Alex, I think you can share the screen and I'll just walk you through.
Sure. I'll present the content for you. Just let me know what you really need. Are we going to use this Notion document?
Yeah, I am.
Okay, sure. Let's go.
Yeah, so for this sharing session, I'll be doing 4.4 and 4.5. So it will be about HDFS and Presto. So what is, I'll just jump straight into the content. So what is HDFS? Like, as the name suggests, like, it is Hadoop distributed file system. So it's a file system that's within the Hadoop ecosystem. So how they store the file is a file will be split into blocks and replicated across like different data nodes to ensure fault tolerance. So fault tolerance is like the capability to operate without interaction. So in this case, a block in HDFS is replicated across like different data nodes. So if a data node is down, no data loss will occur as this block can be found in other data nodes. So yeah, and Alex, you can open the master-slave communication and general architecture of HDFS.
Sure.
So when I previously mentioned like data nodes, what this means is a slave nodes within HDFS. So HDFS uses master-slave communication. So your master node will be a name node, which will communicate with one or more slave nodes, which is the data nodes. So for the data nodes itself, they are slave nodes, so they will not communicate with each other. Yes. So if you guys can see on the image, this is how generally HDFS is architectured, where you have your name node as the master. So they will store it will store metadata on which where a file will be stored, what is the replication factor, and on which data node is being stored at. So as you can see on the images, like your master node, and then you have like 5 different slave nodes, which is your data node, and each slave, or rather each data node will contain a block. Yeah, it will contain a block, and each block is 128. Each block is about 128 MB. Yeah, and it can be stored like in like different. So as you can see from the image, like data node 1, 2, and 3 are stored in like one server rack, and probably like data node 4 and 5 they are stored in like a separate server rack. So if you go on like for the next 2 examples. Next, can you open the example of how HDFS stores a file and a traditional file system stores a file?
Oh, here. Okay.
Yeah.
Here. Oh, you have a lot of content. Please go ahead.
Okay, so as you can see in this example, as you can see in this example, this is showing how HDFS stores the file. It splits it into block and distribute it across data nodes. By default, as I mentioned before, like each data node is 128 MB, so it's rather large for a block size. As I've also mentioned, that the name node, which is the master node, stores the metadata. So how does this like metadata look like? So if you look on the right hand side, you can see that I have a file prefix here, which is the file that I'm showing on the left hand side, which is like 512 MB. So since each block is 128 megabyte MB. So you get 4 blocks, so B1 to B4. And since I have 5 data nodes, so it will be like, so on the metadata, it will be represented as like, oh, block 1 will be stored on data node 2, 3, and 4. Block 2 will be stored on data node 1, 4, and 5. Block 3 will be 1, 2, and 3, and 1. And 4 will be like data node 1, 2, and 5. But as you can see, like, this is, so they have a replication factor of 3, which just means that you have your master copy, which is 1, and then the other 2 is replicated across like 2 different data nodes. So visually here you can see that, well, my file block of B1 is being split across like data node 2 and 3, yes, 2, 3, and 4. And same goes with the other like different the other 3 blocks, 2, 3, and 4. Next, then I think on the previous office hour, I think Alex or somebody asked like, what's the difference between a traditional file system and like something like a distributed file system. So Alex, can you scroll down and show the traditional files? If there's any question, I will answer them later because I can't see the chat, the Discord chat. It's quite small if I expand the Alex, so I can't see the screen that well. So for traditional file storage system, it will be like your NTFS, MacFS, or extension. In NTFS, the default block size is about 64 kilobytes, configurable up to 2 MB. For this example, we are going to use like 2 megabytes, 2 MB as the block size, and the same file size, which is 512 MB. As you can see, within this traditional file system, your file will be split into 256 blocks because you take like 512 MB divided by 2, you get 256 blocks. And they will just be directly replicated, or rather they will be directly stored on the disk without any replication factor, or yeah, it's not distributed at all. So this is the key difference between like a DFS, a distributed file system, and traditional file system. Where a distributed file system, your blocks of file is stored across different data nodes and it has a replication factor. Whereas for the traditional file system, it doesn't really have that unless you say like RAID 0 or different RAID arrays, but that is like a different topic. So moving on, previously also mentioned that in the paper, Uber has a process of using a Parquet and Avro data format. So what is Avro data format? In a basic sense, Avro data format is just a row data format. So think of it like your SQL database, right? Where all your data is stored in like row base, where you have your ID, first name, last name, CPU, and age in like a row, right? So what about Parquet? So Parquet is just a columnar data where all your data is stored in a columnar format, in like shown in the image. Then, so in the paper it mentions that like, it does a conversion from the raw logs that is in Avro format, and they go through a compaction process and merge the data and convert them into a Parquet data format. So why does Uber do this? So for Parquet data format, it is much more suitable for like OLAP queries, right? So OLAP meaning like online analytical processing. So as OLAP queries, they look at a particular data point, like something like age, right? It's easier to query when the data points are grouped together. So if you look at column-based format, the data points of say like age, they are all within like a similar grouping. If you look at the examples that are provided, like find the sum of all the age. If you were to store it in Avro format or OLAP, it wouldn't be really efficient because when you store it as row based, like the data is stored in rows, and when you want to create the age, which is in purple and highlighted in red, it will be scattered across the entire disk. So they would have to like pick up. They will have to sort of like know where the age is and then like do the querying, which can be a bit expensive. Whereas like if you look at the bottom part, which is column data, if you want to do a age query, all the age data is stored within just side by side with each other. So that if the query itself becomes much more efficient. Yes. So if we scroll down, conversely, OLTP, which is online transaction processing, if you were to use a column-based format to do the querying, it wouldn't be as efficient because all the data are all grouped together. And if you can see like all the column data on this storage, if I want to say, like I want to find a user with ID of 1, the query we have to like find, okay, here's the ID, then here's the first name, last name, city, and age, which is all like distributed across this storage, which is not efficient for reading. But if the data is stored in raw data, it will be much more efficient because all the data are just like grouped together in a row, just like how they were inserted. So relating back to the paper, right, the usage of Avro and Parquet in the paper, yeah. So it says that like most of the data comes from Kafka, which is in Avro, and is persisted in HDFS as raw logs. And these logs are merged into the long-term Parquet data format using a compaction process, and it is made available via like the processing engine like Hive, Presto, and Spark. So it suggests, from what I can understand from this, is that it suggests that the raw logs or raw logs in Avro and processed data in Parquet are stored in 2 different directories, because since it's HDFS, you don't really have the concept of a table. You have like directories. I've tried to find like where they actually store the data, but it didn't really show like where they store it. So I can only infer that since they are using a file system, it is more of like 2 different directories. One is for raw logs and the other one is for a processed data, which is in the Parquet format. So when they mention a compaction process, so what is this compaction process? It's simply just consolidating all the smaller files from Kafka, like the logs, and then they bump it up into larger file size. So probably like the 128 MB size of a file. So this helps to reduce the amount of blocks generated. Yeah. So with the compaction and merging and conversion to Parquet, all the data is being processed into like useful information. So Hive, Presto, and Spark can utilize it. I have so. Do you guys want me to go through the questions I have here, or do you just want me to go through like the Presto part, then we go back to the questions?
I think we can try to discuss the HDFS related things first. Since in the chat there's already quite a few questions on HDFS itself. I think you can both answer your own questions and try to read the chat.
Okay. I have no idea why it's 4 rows. Why is the log size 128? I think by default it is. So for Hadoop, by default they configured the block size to be 128 MB. So it's rather large because HDFS prefers like small numbers of files, but they are larger in file size compared to a traditional file system where I showed like NTFS. They have like 64 up to 2 MB, but So this results in a lot of blocks generated due to each block having a rather small file size. So the advantage of like having each block to be like 128 MB is so that the files don't need to be stored across too many data blocks, which might slow down the retrieval and storing process of a single file. So the difference between like a traditional file system and a distributed one is mainly just like the block size, the size of the block, the block size, and the replication factor. If we want to join tables based on some condition, what kind of storage type will be efficient? I'm not, or Xiao Fei Fei, I'm not sure I understand your question. Okay. I will still go through the other questions first. So as I said, like for how is HDFS different from a traditional file system? It's just how the way they handle a block in a single unit, and there isn't a replication factor put in place. What's the difference between a database and a HDFS? So a database is essentially just providing a schema and table to structure your data, whereas a file system like HDFS uses a hierarchical model to store your files, right? Like you have your directory, you have your subfolders and a file. So mainly just the way how the data is being structured, and yeah, it's like the main difference between the database and the file system. Does HDFS have folders? Yes, HDFS have folders. They closely emulate, or rather they are a file system, so they would have like directories and folders. So the next question is, I heard when HDFS or MapReduce got introduced, it is seen as a very unconventional or weird design. Do I know the rationales? No, I don't know the rationale. So what's the difference between HDFS and the data warehouse? So I didn't really get a clear answer, which is why like I just pasted a link here. But from what I can see is HDFS doesn't necessarily replace a data warehouse, more like they complement each other. Because a data warehouse, if I recall correctly, they just process they do much more intensive analytics, and they store like a lot of much more big data, or they have like much more complex queries. Whereas HDFS just processes and provide the data needed for all the analytical queries. Yeah. So for this HDFS portion, is there any more questions? No? Okay, then I guess we can move on
Let me think.
to the.
Okay, I don't have any. Let me ask one question. I think you already answered the thing very well. There's a video you pasted about S3 vs EBS vs a few other things. Have you watched this video, and how do they even compare?
I've watched it, but I don't really understand like their comparison.
This is
I
a very
just pasted it there.
This is a very interesting title.
Yeah.
Like imagine being asked by this during interview.
But I'm not in the interview, so I didn't really like go through the video.
Okay,
Yeah.
sure. Okay, I think Eric helped answer one of the questions, but I think we can just leave there.
I didn't see. I didn't scroll down.
Okay.
So sorry,
Do we want
I missed your question.
do we want to just like start on Presto? Hello.
Yeah, sure. Yeah, we can start on Presto. So for Presto, if you guys can see the code, it's like Presto is SQL on anything, on like that's like their slogan or something. So what is Presto, right? Presto is a distributed SQL query engine. It offers like low query latencies and higher rates of data ingestion. So what is low query latency means? So, or rather, like, it just means when you perform a query between in Presto to your data source, this data transfer is rather low and there isn't much lag between it. So how is this low query latency possible? It's only possible because most of the computations are done in memory. The intermediate results, or rather like temporary results generated during the execution, they are not stored in the disk. So this avoids the overhead of writing the data and reading the intermediate data to and from the disk, which actually slows down the querying and analysis process. Okay. So in the book, in the paper itself, it mentions they use Presto for interactive query and analysis. So what does interactive even mean? Like, so interactive would mean like you have like two people or things that are influencing each other. So like me typing, let's just say like that's me doing a query on the database and then having an output, and I see that I don't really like the output, and I adjust the query according. So that act in itself is interactive, right? I'm interacting with the system to adjust my queries. So in this case, interactive query and analysis refers to the ability to engage in an iterative process of querying and analyzing the data, which is from Presto. So this is where Presto really shine, like because users can actively interact with Presto and receive a prompt response to their input. Meaning Presto is due to the low query latencies, users are able to run like complex queries and get their data, have their data returned to them fast enough, and they are able to see and iterate through the query if the results they want isn't ideal. Right. So if you open up the Presto architecture, Alex, can you click on the image? Yeah. Can you click on the double click on the image? I think it's a bit small.
Is it enough?
Yeah, I think it's big enough for others to see. So for Presto, it works in a coordinator, and it has a coordinator and worker architecture, or rather like setup. So what this means is your client, or so just your client, right? You perform a query, so it goes through a coordinator. So in this coordinator, it is comprised of three like stages. So if you have your parser, planner, and scheduler. So what your parser does is it takes the SQL query and then like do some transformations and sort of like understand what the query means and connect it to like the correct like data sources. And so basically it really analyze the SQL query that is being inputted. So it then passes on to the planner stage where a planner will plan out like what is the most efficient way or route to perform these queries given the amount of workers I have and which data source I need to query the data from. And then you have your scheduler. So your scheduler will just take all this information and run like a schedule to all the workers that's within the Presto ecosystem, in the Presto setup, right? So that they know when to execute this query that is being issued. So for these workers themselves, as you can see here, okay, so maybe one worker is connected directly to a HDFS data source, and another worker is connected to a MongoDB data source. So they will query it, and then the workers will query the data and like they will pump it to like another like just one worker to consolidate the data. And this data will then be returned back to the client. So on a high level, this is how like Presto works. So the Presto coordinator used to submit the queries, manage parsing, planning, and scheduling the query execution across all the workers. And the workers is basically just doing the processing of queries and adding more workers to essentially provide like horizontal scaling to make the query processing faster. So if you scroll down, so there are some, I recall there was a question about like, so what's the difference between Presto and Hive, right? But if you look at this diagram here, so Hive in the book itself, or rather like in the paper itself, it mentions that Hive is also an SQL query engine. It focuses on different capabilities, right? So Hive focuses on batch data processing and query flexibility, which is the ability to query across like large amount of data. And Hive is a vendor locked to Hadoop, which you can only reach from HDFS. And Hive is relatively slow because when you run the query, I mean, so slow in terms of like one query can take up to a few hours. If you want, yeah, it can take up to a few hours to run a query. As you can see, like in Hive, I would not go into details of how like Hive actually works because it will get like quite technical, and I haven't really read too much into it. But on a high level, so every time you issue a query on Hive, it will do like a computation, and then it will store the intermediary data into the disk, and then it will repeat this process over and over again. So there's like loading the data into the disk, reading the data from the disk for the intermediary data. So this, every time you save into the disk, it increases the input and the IOPS. So it reduces it increases the query time because of the reading and writing, and there's a lot of waiting time between the stages. But whereas for Presto, because everything is in memory, right, so it's very CPU intensive and memory intensive. So since there isn't much interaction with the storage, underlying storage, they can just perform all the tasks using like MPP, like which is the massively parallel processing, which they can distribute all the tasks through all the workers. So this allows like Presto to be a lot faster. Yeah, so that's like the main difference between Presto and Hive. It's just essentially the speed of like Presto being much faster than Hive and how they process the data. So what is MPP? Like, so massively parallel processing, it is a technique usually seen in databases. Like you have like some database which uses MPP, but it's just a technique to distribute and execute queries across like large number of parallel computing resource. So this just basically means that, well, in Presto, I have the workers that can act as a computing resource where I can just pump parallel and which I can just execute in a parallel manner to achieve high parallelism and perform a much more efficient query. Yeah. I wouldn't. Yeah. So I think we can do the relating back to paper. So in the paper, it mentions that like we have, so in the case of Uber, like they want to do like some data explorations on the data. To achieve this, Uber has created a connector model that is meant for P-Node. So they created like a P-Node connector that Presto can run its query on. So what is a connector, right? So a connector is basically an API designed to establish a connection between Presto and a specific data source. So in this case, it will be like Presto and P-Node. So using connectors, Presto is able to query from different data sources. So if you can see from, let's go scroll down a bit. Yeah. So in this picture, you can see that Presto is sitting on top of, or rather it can connect to multiple different data sources. Like you have your MySQL, MongoDB, PostgreSQL, Kafka, HDFS, Cassandra, Elastic, Redis. And then in this case, for Uber, it will be P-Node. So which is why in the when I begin this section, I did mention that like Presto is SQL on anything. So it's literally being able to query from multiple or very different data sources. So when developing this P-Node connector, right, there are some challenges that the company that Uber faced. So, so in the excerpt, it mentions that like some of the issues they face given the limited connector API is like they wanted to do a predicate pushdown. So what is a predicate pushdown? It's basically just a technique using queuing processing to optimize the execution. So it's to optimize the execution of queries by pushing the filter conditions to the data source. In this case, the data source here is P-Node. So they are pushing filters down to the P-Node level. So with predicate pushdown, Presto is able to identify portions of the query that can be executed directly in P-Node. What this allows is that instead of retrieving all the data, like maybe you do a select all from P-Node and then do the filtering on the compute level, which is on all the workers, which might take up a lot of bandwidth. So all this filtering is done on P-Node, and P-Node. So when doing the data retrieval on the P-Node level, the filter will help filter all the unnecessary data, and you only get back the data that you need, which reduces the amount of data transferred from P-Node to Presto, and hence improving the query performance. So what are some of the operations that are pushed down to like the P-Node layer? Namely is like projection, aggregation, and limit. What are these, right? So it's simply just like the very basic SQL queries that we usually do. And projection is just selecting specific columns or fields from the data set. Like in this like usual select statement, maybe you are just focusing on like one or two columns that are interested from the table that is being pushed on the P-Node. Aggregation is more of like calculating the summary statistic, like you want your average, you want your sum, all that kind of stuff. So some common aggregation include like sum, count, average, or min or max. So you can see here like there's a sum query and then there's like an average query. So this is aggregation. So and lastly, your limit operation is just simply limiting the amount of data that's returned from the query itself. You just apply a limit operator to the query that you run. I think moving on to the questions section. I think there was one question that says like, well, what is the massively parallel processing? Is it the same as parallel and concurrent computing? No, not really. From what I see, it's like parallel concurrent computing is like a concept on how tasks can be executed in parallel. Whereas for MPP, though it's a technique, but it's like an applied technique where you see like, it emphasizes on the ability to scale up on the parallelism to handle the workloads efficiently. So in this case with Presto, adapting with the worker coordinator setup, they are able to handle a large amount of queries more efficiently by scaling horizontally instead of vertically. And yes, that's all I have for the Presto section. There's 20 minutes left. I think, is that enough for the chapter 5?
Let's ask Rio. Rio, do you want us to just start chapter 5, or do you want us to like do more questions on HDFS?
It's up to you. I mean, my sharing is not that much. It's only about some part of data engineering concept.
Let me think. Yeah, that I guess I can let the audience decide. If you want to hear chapter 5, please type 5 in the chat. If you want to have more discussion on Presto, like try to roast Shin even more, you can type 4 in the chat. Just type 4 or 5. 如果你们想要继续讨论就是第4章的话，你可以打一下4。而我想听第5章讲一些 data engineering，可以打5。5 had 5 这样可以投个票。Okay. Shouldn't you start vote? We are deciding your fate. Okay. Okay. Let's move on to chapter 5, and we'll see if we've had any questions on in last. Rio， 你要分享你荧幕吗
？OK。
好啊，这样我来转播一下你的。Watch。好，看得到，可以。
OK。
来。
Just try to present something, because when I start reading the paper, I have a lot of confusion. I don't really do anything about data engineering, so I want to try to introduce some basic data engineering concepts. So yeah, I mean, it's quite painful when I first read the paper, because I don't know like, oh, what Kafka is doing, what is injection, storage, like this kind of stuff. So just have a quick definition of what is data engineering. You basically take some raw data and produce some high quality and consistent information for supporting, like, for example, if you want to do SQL or visualization, that kind of stuff. And also it consists with a lot of things like security management, data ops, architecture, orchestration, like how the data flows, etc. And the role of a data engineer is to manage the data engineering lifecycle, which I will mention in the next slides, and to make sure we how we make use of the data. So what is actually data engineering lifecycle? Data engineering lifecycle involves, I mean, it just show here. So the generation is like how the data is generated, and it involves a very important part, the ingestion, how you digest the data that is generated. If the data you ingest is not in a good quality, or you wanna make some other data, you need to transfer it. And also the last part is if I mean by the end of the day, you need to use the data to do something else. For example, like machine learning or some analytics. So you need to provide something like an API or something like that. But the underlying thing is a storage. I think like HDFS is one of the storage. And yeah. So how actually Uber the data infrastructure in Uber like? So this is the picture. So they have lots of microservices producing different data. I don't know if you can see here. So it's something like log or some mobile data, mobile app events, and they pass into a Kafka, which is a message queue, I think. Yeah. And the Athena X is a Flink SQL. It's the Flink, so for transformation stuff, and HDFS is something across the ingestion and storage. So this is how it generally look like. And when talk about data generation, actually, there are two common patterns. One is there are several application servers which support a single database, like for example, like some microservices. They will produce some log event itself, and you will just go to a database or somewhere else. And another common pattern is very typical. Like now we're using a lot of smartphones, and when we use an app, maybe we call a Uber ride, and you will send an event log to some message queue, and yeah. So there's two common data generation patterns. And for the storage itself, this is a concept about actually how we think about the storage itself. So the lower part is the more ingredient. It basically means something like physical stuff like hard disk or SSD, like sequential access or random access, this kind of thing. And the middle part is the storage system, which HDFS is one of them. We have something like object stored, streaming storage, this kind of thing. And the top of them, we have something we always see like data lake or data warehouse. But I mean, what are these things? So there are some very usual type of storage system, block storage, file storage, and object storage. Is there any question? I didn't draw the picture by myself. I will reference the book I read at the last. So but when we talk about this free storage system, maybe you don't have any idea what the fuck is actually is it. So I will try to explain what this is. So a file storage is what we always use, like when we have a file explorer, everything is in a hierarchy. We have a folder, we have a parent folder, and we try to access to different file. So if we want to access a file in a file storage, we have a dedicated path. So for example, in C drive, user folder, something else, we can identify the folder using a path. For block storage, is a bit tricky. So every files are divided into So every data are break into a fixed size of block or pieces. which means no matter how large is the file, for example, maybe 64 megabytes, maybe it will trim it to 8 pieces into 8 equal pieces. So this is a block storage. And for object storage, a very famous example, I think, is AWS S3. So you can literally put everything inside the object storage, or a video or image, anything, and you would just store like a container. So so it's like the whole block of the file is stored in the object storage. So when we talk about different storage system, is the physical memory allocation stuff, physical allocation stuff, like how you allocate and how you try to find the files. Okay. So actually, if you look into it, like the storage system and the storage abstraction is actually very distinguishable. Like you can have different file storage system, but still data lake or data warehouse. The underlying differentiation is the underlying point is that data lake is usually store a lot of structure and unstructured stuff. Basically, like can I say like a rubbish bin? You store general rubbish bin. You store everything inside. And data warehouse is more like you store structured data into it. So here's a picture from Go, and it shows like what kind of thing you usually store in a data lake and data warehouse. Then you may have a question. What is the storage? What is the storage abstraction in Ruber? I think when we go back into, okay, this doesn't show it. When we go back to the data, we will see here. The HDFS is a data lake, but why? Because in this HDFS storage, we have some raw data, and after you process the data, and you have some structured data as well. So we will consider it as a data lake because it consists both structured and unstructured data at the same time, I think. Yep. Okay. Let me check the chat if there's any. You use Linux as desktop? Yes, I use Pop OS. So after I talk about storage, I would like to talk about ingestion. So ingestion, I think a few weeks ago we talked about bound and unbound data. At that time I have no idea, so I just Google and find some photos, and it's quite interesting. There's a code about like all data is unbound until it's bound. So actually, the bound data, we just give it some identifier. For example, we can identify bound data by time. For example, like from 2 p.m. to 3 p.m. I want to process this bunch of data. Then it's a bounded data. Or we can deal with the data based on the size. Like for example, if I got enough file, like for example 100 files, then I want to process it into Spark or whatever. So yep, this is the bound data and unbound data, which I didn't know before. And also, when talk about stream processing, there are lots of considerations, like the message schema. Like for example, if there's some message arrives late, or there's some in order duplication, because our message queue doesn't necessarily guarantee the message are to be consumed in order. But another very important thing is the that letter queue. It's for error handling. So for example, when a producer produces some events, so a good event, of course, it go to a consumer, but a bad event, it would go to a that letter queue. But for different uses, for different business use case, we might have come up with different that letter queue implementation, because in some cases we don't want the event just go to that letter queue and don't do anything, because for example in Uber they mentioned like trip receipt processing. They want to do a few retry before you actually go to the that letter queue. So so actually you may, when we think about the architecture, we may need to think about our business use case. Do we need to ask the customer to retry or that kind of stuff? Yeah, because I just start my work this week, so I don't really have a lot of time to prepare a lot of stuff. So these are the two case study from chapter 5, and it shows like how Uber data infrastructure use it for their services like the machine learning platform. Do I need to go through like how it works? Yep. 这个我要说一说嘛。
啊，这个是 Alan 画的图是不是还是怎么样？
对，
啊，是 Alan 画的图，那没关系啊，反正 Alan 就婚礼了，你就讲你可以有办法讲的部分就好了。
这
如果
个我不知道怎么讲，就是
Kafka
这可以放
就是那个
大一点吗？我看一
就是那个
下小的。
这好像是 Alan 画的吧？
壁画的哦，哇塞！
I think it's
好
from
厉
the
害
video. Yeah. Yeah. Okay. Yeah. So these are two case study, like how when we think about some data structure like this, we can go back and see this photo and see how it works. And when you compare these two pictures, everything just makes sense. It always follow a data engineering lifecycle. First you ingest some data and you need to transform it, and maybe you need to put somewhere, like the storage are always across different different process. Yeah, I don't know. I think should I talk as well? Oh, and the book that I'm reading is Fundamental of Data Engineering. So maybe you want to check out the book. Yeah. And it talks one specific thing that I would like to talk about. It's about the storage. He mentioned storage actually is a very complicated part, because nowadays storage doesn't just function purely as a storage. It's always support a lot of other stuff, for example, like SQL or some transformation queries. So so that's why maybe sometimes you see peanuts. It can be a storage, and also it can do some other things, because now storage doesn't only just perform as a storage itself. Yeah. So maybe if you're free, you can try to play some games, like like find some keyword and write it down. Yep. Yep. I I think that's my sharing. I don't think my English accent is from England because I'm very nervous and so I talk.
我们还有其他问题要回答的吗？好像还好，大家都在讨论那个微服务的东西。Copy and write. Oh, you actually have some hidden answers.
Yeah, I mean, if you think about for some time, if you think for a while, you can come up with some answer, I think.
这游戏太难了吧？
It kind of helps you to remember what keywords you learn in the paper and in the book.
Or maybe you should make a crossword puzzle for people to solve.
Yep. Okay. Yeah, that's my sharing. Thank you.
好哦，我们还有什么其他东西聊的吗 ？Eric， 你还在吗？
还在。
想一下啊，好，我们好像确认差不多了。我们先感谢那个 Real 跟 SY 的分享，我觉得他们其实分享的，
我觉得两个人都讲得很棒
我觉得他们真的讲得太好了，就是实在是无可挑剔啊。而且那个上
怎么办？我第一个礼拜讲的应该比这个费很多。
OK， 好，没关系啊，我们没有要比较，大家能够念到自己喜欢的范围就好了。那如果是想要听 sharing 的话，可以就是我们 sharing 会到此结束啊。那我们跟小组现在讨论一下念的进度好了 ，OK 吗？
没问题。
好，我们就有的在场的还有空的组员，SY is typing. Hello SY. Shin, do you have anything to say? 哦，你知道，谢谢。OK，Good job. 好，我们先讨论一下我们要怎么念好了，因为这个 paper 我觉得大家原本起步大家有些人就是可能还刚习惯念 paper 啊，但是我发现我们现在大家每个人都已经蛮熟练的了。然后我觉得我们可以讨论一下剩下章节要怎么拆啊，因为我们有那个第6章是 All Active Strategy 是在讲 Uber 的一些他们的 replication design、backfilling。还有 related word，related word 主要是在讲一些 references 吧，很多就是有点像是，它就比较没有那么 technical 一点的，就很像是讲一些比较巨观的东西啊，跟他们未来可以怎么改进之类的。那个大家有什么想法？就是因为原本读过，
还是我们先来评价一下它的难度，就是凭你的第一印象，然后大家投票一下。
难度哦，
对啊，因为要看怎么切啊。我觉得那2章可能里面有很多小细节。
很多小细节。
对啊，像什么 backup 的那个，如果你没有碰过的话，可能你念不出什么东西。像我就没有碰过这种大系统的 backup 或是 replication。
我会有这样讲，是因为我通常有一个，就是我会开这个讨论，是因为我通常有个印象，就是 paper 通常内容会有点像倒吃甘蔗这样，就是你越念它其实是越简单的，然后后面内容其实通常关键字前面都已经讲过了，然后它放的就比较水一点，就很像是我们看那个忘记哪一章的那个感觉，所以它其实内容会越来越读过就好了。所以我才想说，我们有没有要给后面那么多压力，要把它读得那么细，还是我们就当纯就是比较收尾型的内容这样？这是我当初的想法。
我觉得，就是第六章是关于 replication 那些，那我觉得可能先有个看过，然后有个 high level 的
OK
感
OK
觉，然后在其他的 paper，像 storage 有关的 paper，那我们再深入了解一下，
OK OK 好好
对啊，这样会比较看得懂吧。
OK OK 好。那我们将要决定什么啊？所以我们听起来，我们觉得第六、第七章其实是可以认真念的。
别认
嗯，
真念，
我就没有想，
我觉得先就把它水过就好。
你就直接水过去就好，是不是？那就我们要用什么做法？我觉得有几个做法。第一个是option one，option one，剩下的内容分两个 unit， 4周读完。
那我们还剩哪几组没有分享过的？
我们剩下我标一下，因为也不是每个人现在都在。我看一下，我们人数其实还算是蛮够的啊，就是中途有一些人因为时间关系，他们就是不一定有办法随时参与，可是我们剩下能够挑人力其实是还有不少人，这样就是还是抓得出几组人来帮我们念这样。第一个选项是剩下内容，我们一样分给两次来把它念完，然后还有什么选择啊？还有 option two，
那虽然都应该就全部吃完嘛，一周吃完是吗？
一周吃，还有
两周吃。
2周吃，还是我们有没有一个 option three 啊？就是我们开 O 会少，我们2周吃，但开 O 费少就好，不要 sharing。option three 有点就是把我们的模式改变了一下，但我想说，只有这几张好像不一定有值得 sharing 啊。好，那个 Eric，你帮我想一下，我这样的选项有没有欠缺考量的，然后我们可以来投票
你。在考我力扣吗？考我的真指标。
不是啊，这样我们立刻。我说我们现在有3个选项，然后
今
把
天找一个4周吃完，然后只有开 office hour，
4周吃完只有开 office hour，
对吧？
那要怎么进行？就是 sharing 就跳过，是不是？
对啊，学员都跳过。
开 office hour sharing 跳过。
SY 说 chapter 6 to 10 only，然后6说 if no technical stuff, I don't think we need sharing. Agreed.
Yeah, I think we agree on both of those things. Like, I think the rest would just be like a free form studying. Like, you can even like skip the conclusion based on if you want or not. This is usually the least relevant part for the entire paper. 好啊，如果没有什么其他选项的话，我们就那个让大家想个1分钟。有人在打字，我们让大家给大家60秒。We jump to another paper. No, that's the discussion for like the next month. 给大家60秒，打出你喜欢的选项，可以做。Example 1。好，我做个码表，大家想一下。Timer stopwatch。问编辑，好，快看 edit this timer。 reset. No. Okay, this is bad. Okay, let's vote when this timer reaches 30 seconds. Let me think. Okay, I think everyone kind of voted. We all both kind of voted differently, using different styles.
我原本要弄个投票，就弄不出来。
我说打出来啊！那2周吃只开 office hour 就好。所以我们是
Thanks, man.
谁在说话？
有人帮我弄那个 sticker emoji。
OK， 好，所以是下周有 office hour， 下周也有 office hour， 然后就是讲我们剩下的 chapter， 对不对？就讨论我们的 chapter， is that 对吗
？Option 3 wins, so we
对
do all of them in 2 weeks.
OK， 然后他们说什
And
么
only office hour.
？OK， 第6节第7章 related word， 怎么猜啊？好难哦。I guess we can do 6 and 7. I think 6 and 7 next week. 然后你们刚说什么？第几章可以 skip？ 6 to 10. We can skip chapter 9 as well. What is chapter 9?
Conclusion.
这 lessons learned， 可是我觉得
Lessons learned.
我觉得那个好像其实可以读啊，这个还行吧，内容蛮多的。Anyway, I'll just pack 8 to 10. 8 to 10. (这样可以吗？然后whatever. Oh, 大家觉得这样可以吗？ We will read 6 and chapter 6 and 7 next week, and we'll open office hour for it. And then for the following week, we'll read 8 to 10, chapter 8 to 10, and then you will all be hosted in an office hour style, which is a free form discussion. And then let me check who could be the host. Sorry, the format is a bit ad hoc, but I do need to find someone to do a job. 利友留在这边 ，OK， 利友留在，然后圈后也在 ，OK， 那我们这个让利友留负责好了，利友留，然后这个让圈后那一组，圈后，然后我不知道你们组员都还在不在 ，Titan 好像比较不在了 ，Titan 好像比较7月比较忙 ，OK， 可以。那圈后 ，OK， 没问题，非常的 flexible。那圈后跟，我这样就直接指定好吧？我让那个小飞飞可不可以？因为我看你是下个顺位。然后最后一张我是 Kevin 好了，就 Kevin， 我们让每个人都稍微主持一下 Kevin， 然后加我好了，我帮忙带一下这个东西。刚是他在讲话吗？
不是，是有新加入的同学忘记 mute 了。提话还是怎么不见了？
无视组别的吗？我是觉得 哦，因为我也没有提醒，就是现在在场人已经不太多了啊，所以我们就找个 host 来 host 那个 office hour，然后请他大概整理问题就好。我觉得我们就这样分组吧，因为有几个组员已经有点消失了。Kubernetes 应该还找得到了，对啊 ，Kubernetes 应该找得到，我把 Kubernetes 加进去。Uber 啊，我们 Uber 去哪里了？OK， 好，那就这样咯。感觉这个还可以的设定，最后会比较混乱啊。我还会想一下，就是我们这种每次要念到结束的时候怎么调。那我们就先这样分配吧。好，要是没有问题的话，我倒数个10秒，我们就把这关掉。好啦，那散会了，拜拜拜拜。我会把那个 meeting 时间定好了，拜拜。
感谢大家，拜拜。
拜拜。